Everyone, I hope you are all good.
Hello.
Hi, yes.
Did you have a chance to upload your homeworks?
Yes.
Yes.
Okay. You didn't face any problem?
Professor, can I ask you?
Yes, sure.
Will you upload previous class example? Which we did?
Yes, of course. I'm just today. I just finished on working out the video itself. I just was cutting some part and adding. Okay, today I'm gonna upload it. Just right after the class, I will upload it.
Okay, thank you.
You're welcome. Okay. Today's, if you don't have any questions and comments, I would like to start a new chapter. And before starting it, I would like to just give you an announcement about the quiz and the homeworks that we're going to have. Not the homeworks, I'm very sorry, just mistakenly said homework, but it's exam 1. I'm going to give you a quiz and exam. Quiz I'm planning to give you next week. I'm gonna give you the next week, quiz number 1. And exam I'm planning to give just, I think it will be the last week of February. Last week of the February.
Professor, are you going to make a quiz on Monday? Next Monday or next Wednesday?
Most probably Wednesday. I'm gonna make it on Wednesday. I'm planning to make it on Wednesday. And what will be included, I think it's lecture number 1 and 2 will be more than enough for the quiz. So 1 and 2, you will be responsible for that. But this lecture 3 is not included. Discounting and alternative investment criteria. Okay, I will write on the Moodle and share with you the information. What chapters and lectures will be included in the quiz 1? It's most probably, as I said, lecture 1 and 2. And this will be announced on Moodle as well. So talking about the discounting and alternative investment criteria. These terminologies, you have heard it many times in your finance courses, and you have covered some of it, but this lecture will be differentiated a bit in a different, it will go in a different way. Okay, it's more advanced level of alternative investment criteria. As we know, we have been using like net present value, internal rate of return, and payback rule, discount payback rule, profitability index, and so on. But in here, we will be using only in one difference that we'll take more close to the real examples, the real life examples. What I mean in here that interest rate will be changing every year. This will be the important assumption. And you will see from the examples how it goes. So discounting the time value. So the horizontal sum of the benefits does not consider the time value, actually. And the funds, when they invest it in a yield return, will provide the future consumption worth less than the present consumption. So the present value of the benefits and the present value of the cost will include the timing and discounting the issue. Basically, in here, when you subtract from the present value of the benefits minus the present value of the cost, it directly gives you the net present value. The cost can be in year 1 and in year 2, 3, and the other years could be 0 or other values. So you have to take it into consideration as well. So in here we are given at discounting with a 10%, the NPV, like benefits with a cost, okay? As you can see in this timeline, we have only one cost, which is 1,000, and the benefits or cash inflows. So if you take the horizontal sum, 1,290. However, if you take it as present value of each cash, so when you just take the horizontal summation of this timeline, the benefit actually does not give you a good idea of the benefit that you can add to the companies by using a certain project. So what you are expected to do is to take the present value of each cash flow, what you used to do in your other courses, basically estimating the net present value. And I can just illustrate this example in Excel for you to know how to estimate in Excel. I think that all of you are aware that how to estimate the NPVs using the Excel function. So we have minus 1,000 here, and the cash flows are here, 200, 300, 350, 350, and 1,440. And the discount rate is 10%. And if we estimate the NPV,
Excuse me, Professor.
okay, I'm not sharing the screen.
We
Okay.
don't. Yeah.
Just a second. Can you see it now?
Yes.
So this is the cost. So my NPV function in here so I put first rate. Does anyone who doesn't know this function? Anyone in the class? Okay, everybody's familiar with it. Just take it into value and subtract the investment cost. This is what I get as NPV. Okay. So this is the NPV. So basically you were discounting each cash flow and getting the net present value. This is the best thing that could be done in estimation the cash flows for the project. So choosing an appropriate discount rate is critical because of the fact that small variation in its value can significantly change the results of analysis and affect the final choice of the project. So discount rate is an opportunity cost of funds that are invested in the project. So in analysis, the discount rate depends on the viewpoint of the analysis. So when economic analysis of a project is being conducted, the relevant discount rate is the economic opportunity cost of capital for that country. So as we can see here, like sales, net cash flow, so you just make estimation and this is what you are coming up. And net cash flow, this is how you estimate certain cash flow projections, okay? 1,400. And we just, is it good investment? We cannot answer before estimation the NPV. We need to estimate, we need to take the present value cash flows and present value of cost in order to understand whether the project worth to invest or not. Of course, we have to use the discount rate, and the discount rate, as it has been said, that it is the cost of capital for specific project or for the specific country. And this is a thing that you know it already, basically. There is investment criteria that you are familiar with is NPV, IRR, modified IRR, benefit cost ratio, payback period. Okay. And NPV, how it's been estimated is here. It's an algebraical sum of the present value of the expected all incremental net cash flows over the project life. And NPV measures the change in the wealth that creates a contribution to the project. When the NPV is zero, the investor can expect to recover the incremental investment they have incurred to earn a rate of return on their capital equal to the private cost of capital for certain project. So that basically they will be in a break-even point. And NPV is equal to zero at the rate of IRR. This we know as well. Okay. So if that there is a mutually exclusive project, there's like you need to compare like some projects with each other, and according to some benchmark, you can choose it only one project. If NPV is more than zero, that gives you the positive value as additional to project or to the firm. So that could be created a additional value to the firm, to the shareholders' wealth. So we are given here the rate. We are assuming that the rate is fixed, okay? And in here, the assumption is made like this. NPV for year 0, which means that you will bring all the expected cash flows to the year 0. What if the NPV to the year 1? So that you need to bring everything to the year 1. So bring all the stuff to the year 1. So you bring, what I mean here, bring this 1,000 here and bring this values to year 1. So these values will be discounted, but this value will be compounded. But when it says NPV 2, estimate the NPV for the year 2, so here. So that means that you will bring these values to year 2, and you will bring this value to year 2. So these values will be discounted and this value will be compounded. If you bring into the year 3 the NPV, so which means that you have to bring all the years before year 3 to here. So bring in these values to the year 3 and bring this value to the year. But when you do the NPV for the year 4, so which means that you're bringing all the values from year 0 to year 4. You are just compounding all of the values. And in year 4, $1,440 is equal to the $1,440. It doesn't change in the value because it is the same value. Okay. So suppose the discount rates may change from year to year over the life of the project. Like we have R0, R1, R2 are discount rates for the year 0 and year 1 and year 2 respectively. So the NPV of the project in year 0 is calculated as follows, okay? For the year 0, when you bring it, so you should consider all of the rates. Like for the first cash flow, only the first discount rate is considered. For the second cash flow, 2 discount rates considered. And for the third cash flow, 3 discount rates considered. So this is how we deal with different discount rates. Okay, now there's an example is given. I'm going to illustrate it using Excel. Okay, same. So in Excel function, let me put this rates 18, 16, 14, 12, and 10. It's like reduced by, so it's 18. I'll just copy this. So this is 18. This is 16. Okay, this is how it works. So which means that from year 0, let me put the number of the years here. Okay. Yeah, 1, 2, 3, 4. 4 years, okay. These are the years. Okay. And these are the cash flows. Cash flows, and these are the discount rates. Now, these discount rates are distributed in this way. From year 0 to year 1, it's 18%. From year 1 to year 2, it's 16. From year 2 to the 3, it's 14. And from year, if you compound it. But if you discount it, you're bringing back. So if we just, before solving this, I want to illustrate on the slides how it works, okay? So now if you estimate the NPV of year 0, which means that you need to discount all the values to the year 0. If you're estimating NPV of year 4, that means that you need to compound all the values to the year 4. Does it make sense? NPV 0, NPV 4. NPV 0, we discount all the values to the year 0. NPV 4, we compound all the values to the year 4. Do you get the differences? Please, if there is some concern, okay, if I solve the question, that will be more clear. So when we discount, when we bring all the values, if it was just one rate, we would use just 18%. Let's say it's just 18%, okay? We would just divide by 18 each value, okay? We would divide just 18 by each value. However, there is no, from year 0 to the year 1, there is only 18%. But from year 1 to the year 2, there's 18 and 16. So that means if I bring this 200, okay, this is 18. From here I have 16. From here I have 14. And from here I have 12. Okay, if I discount 200, which means that I'm bringing to the year 0, 200 divided just by 1.18. Then I bring this $300 to the year 0 as well. If there was only one rate, let's say 18%, I would just raise it to the power 2, the 18%. However, we have two different rates. So this $300 pass through 16% and through the 18%. So which means that 300 divided by 1.18 multiplied by 1.16. Then this 350 passes through the three different rates, 14, 16, and 18. So 350 is divided by 18, by 16, and 14. So it passed three rates. And 1,440, it passes four rates. It passes four rates, 12, 14, 16, and 18. So that means, sorry, yeah, four rates, 1, 2, 3, 4. 1,440 divided by 18, 16, 14, 12. 18, 16, 14, 12. This is how it works. So to illustrate it in Excel function, however, in Excel function, we cannot use it, the NPV like this. So that means we have to do it NPV 0 manually. Everything should be manually. What do I advise you to do? Not to be lost. You can type everything in single formula, but the best thing that could be done is do everything like separately. Start with 200. 200 just passes 18%. Let me just make it like this. 18, 16, so not to be lost. 14 and 12. These are the percentage that each cash flow will pass. Now, for 200 divided by 1 plus 18. This is what I get it, okay? Then I move further. 300 divided by 1 plus 18. We close the bracket and times, open another bracket. 1 plus 16. So basically what I do here, again, 200 divided by 1.18. In here I do 300 divided by 1.18, and this of course multiplied by 1.16. We don't raise it to the power because the interest rate does not repeat. If the interest rate repeats like 18 here, then you could just raise it to the power 2. Okay, let's move further. Here I just do this 350 divided by 1 plus 14, 16, 18. So which means 18. I close the bracket times 1 plus 16 times 1 plus 14. And I close the bracket again. This is what I get discounted cash flow for 350. And the last one, I can just copy this one and put it here. Okay. So as you can see here, what you need to add it here, I can just add in front of it. 1 plus 18 times this, okay? So this is what I get it. This is what I get it. Now I need to just sum it all and subtract the investment cost. That would give me the NPV. Sum all. And investment cost. This is my NPV. So basically what I do here, again, 350 divided by 1.18 times 1.16 times 1.14 and so on. Okay, this is how I get this, and this I got 1,440 divided by this all discount rate that I get it. Okay, let me check something. Okay, this is what we get it. Do you have any questions up to now?
No.
Okay. Now, if you're asked to calculate, let's say NPV1, which means that you have to bring everything to the year 1, so to here. That means this 1,000 should be compounded. 1,000 should be compounded. Okay. If I bring it here. Okay. Now, if you want to bring it to the NPV1, that means you have to compound all the values. You compound 1,000. You compound 1,000. This you do not do anything for the 200 because 200 in year 1 is equal to the 200. You don't compound either discount. So compounding means that 1,000 it will pass only 18%. So multiply by 1.18. Now, then 200 is 200. then we have to discount all each cash flows to the year one. So 300 only, what I can do here, okay, I just say, drag it like this. Okay, let me. So 300 divided by 1.16. So from 300 to the year 300 from the year 2 to the year 1, it just passes only one rate. Then it will pass rate 16 times 1.14. So it will pass two rates, 14 and 16%. And if we divide it, and this 1,440 will pass actually three rates, 12, 14, 16. We have 16, 14, and we should add it 12, 1.12. And if you sum it all, sum them all, you should get the NPV. Oops. This is my NPV 1.
Professor, I'm sorry, can you show again the formula?
Yeah, sure. I'm going to repeat it again. Don't worry. I'm going to repeat it again. I will do one more example with you.
Thank you.
Okay, let me just delete this. Okay. So let me just delete everything. I will repeat it again. Okay, we're given different rates. Let's calculate NPV0 and NPV1. NPV, first of all, if it's NPV0, that means we have to bring all the cash flows to the year 0. Any cash flow in year 0 is equal to the amount which is equal in year 1, in year 0, sorry. So it's just 1,000. We take it as it is. 200, as we can see, it just passes 18%. Divided by 1.18. 300, it passes 16 and 18. Divided by 1.18 times 1.16. Be careful, guys, okay? From my experience, the students, they always forget to put the brackets when they multiply the rates. If you don't put the brackets, the Excel function does first whatever comes from the left to the right, okay? It just divide, then again it multiplies. So first of all, it should multiply whatever in the bracket and then make a division. So do not forget to put the brackets. So 350 divided by 1.14, sorry, it starts from 18, let's say, times 1.16 times 1.14. And 1,400 is times by 1.12. Do you have any questions up to this point? We just discounted by considering all the rates.
No question here.
Okay, great. Now, what you will do for the NPV, you can just sum it all. Sum them all. That is your NPV. Sum function. Or, if you prefer, manually calculate everything. This plus this plus this plus this plus this. You can do it in this way as well. Yeah, it's up to you. And let's do the discount for NPV1. NPV1, which means that we need to compound the 1,000 to the year 1 and discount the cash flows to the year 1. So 1,000 times 1.18, then 200 divided by 1. It's 18 to the year 0, which means 1. So it's the same, it doesn't change. And 300 we're bringing to the year 1 from year 2. So divided by 1 point. From year 1 to the year 2, there's an interest rate of 16%. And from year 3 to the year 1, there are 2 interest rates. It just passed. It's 14 and 16. So I open the brackets here. Times 1.14. And I discount this cash flow as well. It passes 3 rates, 12, 14, and 16 times 1.12. One more time, take it to your attention. Do not forget to put the brackets when you do the multiplication of the interest rates, when you discount it or compound it. Otherwise, it just straightforwardly calculate from the left to the right. That would bring you the different results. For illustration, I can just remove the brackets to show to you. It was 972, but now you can see what will be the answer. It becomes even more. So which means that you discount it first, then you compound it twice. Okay, then you just sum it again. Sum. You can add manually everything, or you can just sum it with a sum function. It's what you get it. And while you're calculating an Excel function, please pay attention to comma separator and the decimal separator. Okay, in some of your Excel function, it's instead of dot, it's given comma as a separator of the decimal, but in some of you it's a dot separator of the decimal. If it's just comma separator, not a decimal, it might not calculate. Okay, if it's in your case, if it's a decimal separator is the comma, and if you put the dot, you will not get the results correctly. Pay attention to it, okay? Let me check it. Yes. And let's do the NPV2. NPV2. So NPV2, that means that I have to compound to the year 2. 1,000 so this 1,000 compounded 1.18 times 1.16. $200 is compounded through one rate, 1.16, and 300 is 300. And I discount the cash flows of this 350. Let me copy and paste. So I just, as you can see, just passes from one interest rate from 14%. So 350 divided by 1.14. And this, it passes two rates, 12 and 14. 1.14 times 1.12. 598. 598. Did I get correctly? Yep. Okay. Okay, let me save this file just in case. MPV example. Okay. Do you have any questions? Okay, it seems that everything is clear. Great. So, interpretation and the decision. I don't have to spend a lot of time in here because you already know that if it's more than 0, you accept the project because project returns are greater than the cost incurred by a certain investor. If it's equal to 0, the project earnings and the costs are equalized at a break-even point. So you're in a different position whether you run or not. And projects, when it's less than 0, the MPV, the project does not generate enough revenue to cover the cost. So you basically reject the project. So MPV is used as a decision criteria to answer the following question: when to accept or reject the project, how to choose the project under the certain budget constraints, which means that if you're given 5 different projects, you can, if the projects are, you have a budget limit, you cannot choose all of the projects which are positively, that has got the positive MPV. However, you will do your decision in accordance with your budget. If your budget is 1 million and there are 5 projects and each project, let's say 1 million and some of them is 3 million. So that means you cannot choose all of the projects. You will choose only those that you will be able to afford it. And the third question that it answers is how to choose the project from mutually exclusive alternatives. Like you can choose only one project. The budget constraint is not playing any role in here, but you choosing only one project and that project with highest MPV. So when to accept and reject the project. So you do not accept the project unless it generates positive MPV. We know it all. And examples are given here: 70 minus 50, 100, and 25 minus. So you select only the positive, like project A and C are acceptable. You are worse off if you select project B and D. When you choose according to budget constraint, suppose you've got the budget constraint of 4 million, and what you can see here, like project A, B, C, D, they all offer you a positive MPV. However, it doesn't mean that you can select all of the project. You can only select in here that will satisfy your budget constraint, either project B and A, because your budget is constrained at 3 and 4 million, in total 4 million, or you can select C and D. You can select D and A, C and A. However, you cannot select D and B and C and B because of the budget constraint. If you select B and CB or BC project, that means you have to spend 5 million, which you don't have it. You have only 4 million to spend. And in a situation where there is no budget constraint, but the project must be chosen from mutually exclusive projects, alternatives. So we should always choose the alternative that generates the largest NPV. So in here we select with the largest NPV, which is project F. Although the project G has got highest NPV per dollar of the investment as well. We cannot select, we can select only F. IRR is the internal rate of return for a project that refers to a discount rate at which the present value of the benefits are just equal to the present value of the cost. And we know that when you use IRR in the NPV function, it gives you directly makes your NPV 0. So IRR criterion has been considerably used by both private and public sectors as way to describe the attractiveness of the project. And it is a common interpretation are that if the IRR is greater than the cost of capital, then the project should be accepted. If the IRR is equal to the cost of fund, then the investors are expected to recover their invested capital and earn a rate of return equal to IRR. So IRR is less than cost of fund, the project should not be taken. If IRR is not reliable investment criteria, as there were several problems associated with this, like we will discuss below. So main advantages, it's easy of communication and solely relying on the information from the project. Disadvantages are listed here. The IRR may not be unique. IRR cannot handle mutually exclusive project of a different scale, cannot handle the mutually exclusive project with a different length of life, and cannot handle the mutually exclusive projects with a different straight starting point, and cannot handle irregular cash flow. So these 5 disadvantages makes the IRR down in prior to NPV. So NPV is the best investment criteria that could be used. However, in reality, especially in Kazakhstan, as I understood, as I've seen in hedge funds and investment bank, when they do investment appraisal, they use IRR more frequently than NPV. And the reason is that even though there are many pitfalls that are underlined in here, at least 5 pitfalls, you can see it. The main idea was easy to interpret the results of the IRR.
Even if NPV shows that the project is not
yes,
returnable.
Yeah, no. The issue is that in here they don't use the NPV that much frequently as IRR in Kazakhstan.
Okay.
This is what I understood. The reason is they're easy to interpret to the investor.
Mm-hmm.
The investor,
Okay.
they don't want to, because we know that many investors, they don't know about, I'm not talking the investors in financial instruments who are educated. There are like many investors who are not educated, but they have money and they want to invest the money. How easily you can interpret is just showing the IRR. IRR is your return. Either you cover your cost, either you return more than you cover.
Okay.
So this problem 1 that IRR has may not be unique. So there's a root mathematical equation which is based on the time profile of the incremental cash flow. If the time profile crosses the horizontal axis more than once, then there is a possibility that there will be more than IRR, more than one IRR. So which IRR to choose, you don't know. You're in kind of dilemma created. You don't choose the highest IRR in the same project. You can choose the highest IRR if you compare to different projects. So the IRR will not have a unique value if the negative cash flows are all in consecutive years. So if the risk analysis carried out for a certain project with a life of more than 2 or 3 years, there will be almost always be scenarios where there is 1 or more negative cash flows in the future. So this will create more IRRs. So of course, eventually it will generate the false interpretation of the IRR. So we can see that case of mutually exclusive project with the different scales, MPV gives you the highest for project B, but for project A, it gives you the lower MPV. However, according to IRR, it tells you to select. So there's a misleading interpretation of the IRR. So we cannot rely on the IRR in this case, but we know that the MPV is as a best investment criteria, which is acceptable actually around the globe. And this lecture, by the way, designed by one of the who worked in Ministry of Economy in Canada. His name is Glenn Jenkins. He organized and he's delivering the lectures related to MPVs and the IRRs. And he's using in his investment appraisal projects the MPV as an investment criteria. Like he's using IRR and the MPV together to just make comparison, but the final decision is based on the MPV. So mutual exclusive project with a different length of life. Okay, when the projects have got, one is 10 years, the other one is 5 years. And in here, the IRR just calculate, it gives you, as we know, there's one thing that we cannot estimate the MPV as well in here. Okay, so what we need to do here, if anyone has taken any finance course, and remember, there's one methodology which is called least common multiple leave approach method, or somebody's already taken it now. You should remember that the MPVs cannot be estimated for the projects if they are different length of life. But still, we can do the MPV and make arrangement, and still the IRR will give you wrong and misleading information. So mutually exclusive project that start at a different point of time. So one project starts today, the other project starts 5 years from now. Okay, and they will last for 2 years. Both projects, and as you can see, the MPV for the first one that is given a higher, but IRRs give you for the project B. And the mutually exclusive projects with irregular cash flows, as you can see, the IRR is misleading you, and misleading in terms of that in one project we may have different IRRs, like more than one IRR. So that makes us not to rely on the project using the IRR. So problems associated with IRR criterion examples, project B is obviously better than project A. This is what we said, because, but IRR is A preferred. For project C is obviously better than the project B. According to IRR, B is preferred to C, and project D is worse than project C. According to IRR, D is better than C. And project E is worse than project D, but in accordance with IRR is vice versa. So according to this, we can make some conclusion that MPV could be used as a best investment criteria. Okay, we have here modified internal rate of return. Okay, I will start on it, but I want to give an activity to cover and get supported from the knowledge you got today, especially the MPV, so that I don't want you to have any problems in running the estimation, the MPV, with the different scales. So modified internal rate of return is the financial measure of the investment attractiveness. It is used in a capital budgeting to rank the alternative investment of equal size. So as the name suggests, that MIRR is a modification of internal rate of return, such as aim to resolve not all of them, but some of the problems. So first of all, you discount all the negative cash flow to the beginning of the year of the firm's cost of capital or country. Compound all the positive cash flow to the end of the project's firm's financial cost of or country, cost of opportunity cost of capital. And now we have one initial cash outlay and one future benefit at the end of the project. Then we can calculate IRR between this one negative value at the beginning of the project and one positive value at the next. So what can be done in an example here? So as you can see, we have negative cash flow here, positive. So what we do, we just discount this negative cash flow to the year 0, and we compound all the benefits to the last year. So this compounded value divided by this discounted value and raised to the power 1 over the life of the project. If the project is lasted for 5 years, then you will divide 1 over 5. And at the end, of course, minus 1. That will give you the IRR. This is how estimated. For example, I can show you quickly here, but we'll practice more. Let's say we can do the same example. 1,000, 1,200, 800, 3,600, and minus 8,000. And the years are 0, 1, 2, 3, 4, 4 years. What I do basically, it said that we need to discount all the negative cash flow to the year 0 and compound all the cash flow to the year here. But we are using in here only one discount rate, okay? We're using only one discount rate. We're using only one discount rate. But what if the discount rates are this? So let's try with one only discount rate, 12%. So 1,000 times 1.12 plus 1,200 times 1.12. Am I correct? Let me do it one by one. For this one, is this correct? I want to compound to the last year.
You should do it to the power of 4.
I should raise it to the power of 4. Very good. This one, I should raise it to the power of
3.
3.
That's it. I raised all the values. Now I can just bring this 8,000 back. 8,000 discounted. So I will just discount this 8,000. But before that, I need to sum it all. This plus this plus this plus this. So I get this one. And eventually I get the value 8,000. And what I do here, just open the bracket, 8,000 divided by 5,000, and we're raising to the power of 1 over 4 and minus 1. Course.
Sorry, can you show how you get 5,000?
Yes, sure. I'm going to show you again. Just a second. Now, I just discounted this cash flow. I took this one to the year 12. Sorry, to the year 0 with a 12% discount rate. I just discounted. So this discounted this. So in order to have a positive number when I do estimation for IRR, MIRR, so I just take it into account. It's a positive absolute number. Okay, I just remove this negative sign. I just put it minus in front of the equation to get positive number at the end. And then, according to the formula, future value of benefits divided by present value of the cost and raised to the power 1 over the life of the project. Here. First, you get negative number, but you remove this negativeness when you estimate MIRR. And this is, we assume that it is only one rate. There's only one rate. This we only assume. However, there are more than one rate. Can be the case, like the example given here. This one I can go next Monday. We'll work on that. We'll have more examples. We'll solve more example. But I want you now. If you have any questions, please feel free to ask now.
And I just want to make sure that the main assumptions in modified internal rate of return are that all negative cash flows we discount back to the beginning of the year, and all the positive cash flows we compound to the end of the year, right?
Yeah, very good. That's very true.
And
then all the future benefits that you compounded divided by
present value of the costs.
Yeah,
right?
What we do here, we divide and we raise to the power 1 over 4 to get this 13%. Okay, let me take quick.
Professor, I have one more question.
Sure, of course.
Can't we use some formulas like formulas of Excel like MIRR?
Yes,
Excel.
you can use it. Very good. You can use that function. However, if its rates are different, how are you gonna deal it with this? Then you have to manage it separately, manually, one by one. In this case, you can get it. In this case, you can make it, okay? I never tried it, but let me just see it. We put the rates. So anything we need to put here? Yes, we need to put some finance rate, which is 0.12, and reinvest rate, which is 12. I never tried it, this function. Yes, it works.
Okay, got it. Thank you.
It works.
Professor, can you show one more time? How do you calculate?
But one more time, guys. Yes, which one?
Yes, this one.
No. I mean, with the function.
Yes.
Okay, one more time. What I did here, I typed MIRR, I selected the range, and I put finance rate, which is 12%, and investment rate, reinvest rate, which is 12% as well. It's a cost of capital, both finance and reinvest rate. And that gives me the, what do you call it, MIRR. Okay, they're exactly the same. But what if you have different rates? Then when you compound, you have to compound with all different rates, okay? Taken into consideration. And when you discount, you have to take into account all the rates. But we just did it with one, with 12%. Okay, do you have any questions?
Yeah, Professor, the last
No
question
questions.
is
Yes.
that the logics for IRR is the same for MIRR, right? Which is, if you want to accept the project, the MIRR should be greater than the discount rate.
Yep, very true, very true. And did you get the difference why we are using the MIRR in here? Why there is a need to do this?
Yes.
What is that?
Because the cash flows are distributed not as in the traditional way, which is initial cash outflow can be anywhere, right? Or not.
Very true, very true. And it solves some problems of the IRR. However, not all of them, some of them. So the main idea, you improve your IRR estimation. Okay, there was somebody else who was asking the question. Was it Almat?
No, I have no questions.
Okay. Okay, if you don't have any other questions, let me take the attendance before it just times out. Aidana is here.
Here.
Okay. Lee,
I'm here.
Evgenia,
I'm here.
Alnur,
Here.
Almat,
Here.
Marina,
Here.
Saken,
I'm here.
Anwar,
I'm here.
Dinara,
I'm here.
Dana,
I'm here.
Temirlan,
I'm here.
and Can.
I'm here, Professor.
Okay, everybody's here today. Good. Very good. Okay, once we have 10 minutes, let us talk about, if you don't have questions related to this chapter, I will stop on slide 28, 29, and I will continue on Monday. But concerning your data collections, how's it going? How's your data collection going?
We're still collecting.
Work in process. Professor, can I ask you, I just forget, should we collect the information for 2019 and 20, right? Or just
Yes, it's very preferably 20. I want to capture the pandemic as well. Because my idea is to see how the pandemic affects the risk management decisions. It's a credit risk management, it's a liquidity risk management, and other types of risk. So I want to see.
Professor.
Sorry, yes?
Some companies, and in my case, banks, did not publish their financial statements for 2020 yet.
So select those companies who published it. That's why I ask you, please select the countries properly. For example, in Kazakhstan, I can see like some of the banks, they publish up to date in 2021, even for the January, they published as well. They monthly publish their statements. So select those banks which publishes. It's very it's very preferable to select those because the idea is to capture this pandemic effect. During the pandemic, how did they perform?
What is the deadline for us to collect all the data?
I was planning to give you the deadline. It was the middle of the February. So you have, let's say, 3 days and 10 days from now. 10 days.
Okay. And how many companies we need to? All of them?
Five.
Or
At least five.
at least five? Okay.
Yes.
Okay.
At least five. For how many years do we need to collect the data? For all the years that are available, but preferably to capture the last year. By the way, there is a thing that I found it for microfinance companies, for the small enterprises. I found a website where you can reach the data. I will share with you this. I will send the email. I'll share with you as well the link itself. Okay, we've got 7 minutes. If you have any questions concerning the startup program, on Monday, I will show you where I uploaded the Stata program, where you can run it. So I will upload it there. You can reach it and use it. And I will show you how to use. Some of you already know, but some of you don't. But those who doesn't know, you will see how to use it. So for example, the statements from 1999.